Yeah, good afternoon, students. It's my pleasure to introduce this classroom discussion topic on single linked list. So this is third unit topic. Okay. So now I would like to share my screen. Hope my screen is visible to you. Yeah, this is week 8 lecture 1, basic terminology of linked list. Summary of the previous CDT is that we discussed about the priority queue. So it is a data structure in which each and every element is associated with some priority. So based on that priority only, we can able to perform the insertions and as well as the deletions. So when we have two or more elements with the same priority, so those elements will be processed in first come first served basis. So this is what the priority queues we have discussed in that. Now coming to this lecture objectives, so the objective of this today's session is that to know the differences between arrays and linked lists. And the outcome of this session is that after completion of this CDT, students will be able to analyze the differences between arrays and linked lists. So what is meant by linked list? So linked list is a linear data structure. So the data items in the linked list are not in consequent memory locations. So every linked list is having some set of nodes, and each node is having data as well as the link field. Okay, so we can call it as a data and the link, which is also called it as a next, we can say it as. So a linked list is defined like this. It is a collection of nodes where each node contains one or more data fields and a pointer or a reference to the next node. So the last node points to a null reference to indicate that end of list. So this is the node structure. So every node will have data and the pointer which is used to store the next node address like this. So this is a node 1. So it is storing the data 1, and it is this is a link field which is used to store the address of this second node. So like this here, these are the nodes we are calling it as. This is node 1, node 2 and node 3. So like this we are storing the nodes, and each node is having a data field, and this is what the data we are calling it as, and this is what the link field. So which is used to store the address of this next node in this list. So and in this linked list, this is the last node, we are storing it as a null in the link field. And the starting node address, we are storing that to access any node in the linked list. We require to know the starting node address. If you know the starting node address, we can access any node in the linked list. So for that particular purpose, we are taking a header node. So this is called it as a header node. In this header node, we are storing the starting node address. We are storing that. Fine. So this is what we are calling it as a single linked list. We are calling it as because we are storing only one link field in this every node. So this is a definition for this node structure. Struct node int data and then star next. It is a pointer which is of type again structure node type. Fine. So this is what the node is basically. And coming to this linked list representation in memory, it will be like this. For example, if you're taking this is a data field and this is the link or next field, if you take it as. So here this is the start, which is the acting it as a header node. So we are storing 1. So if you are coming to here, H is the data and 4. So we are going to 4. So this is what we are coming here. So E and then 7. So we are going to 7 here, L and 8. So we are coming to here, L and 10. So here we have O and -1. So -1 indicates that this is the null. Okay, this is a null. So start pointing to the first element of the linked list in the memory. So what are the advantages of linked list? Linked lists are dynamic data structures where we are storing the memory and allocating the memory dynamically. So linked lists have efficient memory utilization. Insertions and deletions are easier and efficient, and more complex applications can be easily carried out or developed through this linked list. So these are the advantages of linked list. So the disadvantages of linked list is that it consumes more memory space, and also the searching a particular element in the list is difficult and time consuming process. And types of linked lists we have seen here is that single linked list and double linked list. and then circular linked list, circular double linked list. So this table will show you the variations between these arrays as well as the linked list. So arrays are static, memory allocation will be done at compile time, and for linked list memory will be allocated dynamically using the dynamic memory allocation function. And these arrays elements we can access randomly by specifying the array index. Suppose A of 10, if you specify that. So you are accessing the 10th index location element. But whereas here in linked list, you have to access all the elements in sequential manner only. So arrays will occupies less memory than linked list for the same number of elements, whereas linked list will occupies more memory because of the link field. Link field is also occupies extra memory in every node. Insertion at front is potentially expensive because of elements need to be shifted in the array. Insertion in a linked list is carried out easily. Similarly, deleting an element in array is also a costly operation, whereas in linked list, deleting an element is easy. Just by adjusting the link fields, we can do that. Fine. So this is a reflections part 1. So now list the advantages of linked list. And LOs are revisited here. After completion of the session, students will be able to know the differences between the linked list and the arrays. So summary of the session is that linked list is nothing but it's a linear data structure. The data items in the linked list are not in consequent memory locations. Linked list hold the data in the form of nodes. A linked list is a collection of nodes where each node contains one or more data fields and a reference to the next node, and the last node points to the null reference to indicate the end of the list. And this is a lecture level practice problem. So compare arrays with linked lists. And these are further readings on this particular topic. Okay, so thank you one and all.